Okay, we're going to look at number 8 again. If you're watching my other video, I lost my connection. So let me just start at the beginning for number 8. So sorry about that. So this video covers the remainder of the review. So to express this in vertex form, the first thing I'm going to do is I'm going to move the 3 over. I'm going to add it to both sides, get it out of the way. So we have f of x plus 3 equals 5x squared plus 30x. Now to put a quadratic function into vertex form, I do need to complete the square. But before I can complete the square, I need to factor out a. You can see the a appears in front of the square of the binomial. So I'm going to pull out a 5. Even though I could also pull out an x, I'm not going to pull out an x. I want to leave this as, I'm going to work to get this to be a perfect square trinomial. So I need it to have an x squared term and an x term. So I factored out my 5. Now I'm ready to complete the square. I'm just going to use CTS for complete the square. So to complete the square, we're going to take the coefficient of x, we're going to divide it by 2, and square the result. So coefficient of x, divide by 2, square the result. The coefficient of x is 6. We're going to use this coefficient of x, not the 30, because we're trying to complete the square inside the parentheses. Going to divide it by 2, square the result. This is going to give me 3 squared, which is 9. So I'm going to add 9 inside the parentheses to create a perfect square trinomial. Now, whatever we do to one side of an equation, we've also got to do to the other side. I'm just going to leave a blank there, and I'll come back and discuss what we're going to add to the left-hand side. So I'm adding 9 to the right, or inside the parentheses here. You may think, to keep the balance, I want to add 9 to the other side as well. Well, I did add 9, but I put it inside parentheses, and there's a multiplier in front, this 5. So by adding the 9 inside the parentheses, the effect that that has on the right-hand side of the equation is actually adding 45. You have to distribute this 5 to the 9. So I'm distributing here to see what effect that 9 has on the right-hand side. So it actually has the effect of adding 45. So to keep the balance, I need to add 45 to the left side. Okay, we're almost done here. Let me see if I can, let me move this down a little bit. Give myself some more room. Okay, so I have f of x plus, I can go ahead and combine like terms, 48 equals 5 times the quantity. So completing the square will create a perfect square trinomial. X squared plus 6x plus 9 factors as x plus 3 quantity squared. And then lastly, I do want to isolate my f of x. I want to move over that 48. So I am going to subtract 48 from both sides of the equation. So vertex form is f of x equals 5 times the quantity x plus 3 squared minus 48. So this is vertex form. It also asks us to state the vertex. So nice thing about vertex form is to state the vertex, it's pretty quick. The x coordinate comes from inside the parentheses, the y coordinate comes from the outside. However, we do take the opposite sign from inside the parentheses and the same sign on the outside. It has to do with the fact of how this vertex form is written. Inside the parentheses, we have x minus h. So our vertex for this problem would be a -3, -48. So that is the vertex. Okay, let's look at number 9. Number 9, we are asked to find a couple of composite functions. So it asks us to find f of g of x and then g of f of x. This is equivalent to this notation. So same thing. So if you're confused by the notation, it just means f circled g of x. So this is where we plug g into f. So the function f is 6x squared minus 5. But in place of the x, we are going to substitute in g. So I'm taking the function f and I'm going to plug g into it where I see the variable x. So this becomes 6 times the quantity 4x plus 7 squared minus 5. I am going to square first by order of operations. I can't distribute the 6 just yet. I can't distribute the 6 at this step. So I'm going to square that binomial. And so when I FOIL, I get 16x squared plus 28x plus another 28x. So let me just go ahead and call that 56x plus 7 times 7, which is 49, close my parentheses, minus 5. Now I'm going to distribute my 6. 6 times 16 is 96, so we have 96x squared plus 6 times 56. Okay, I'm going to use my calculator here to the side. That is 336. So 336x plus 6 times 49. 6 times 49 is 294. And then don't forget, we still have this minus 5 here in the back. So combining like terms, we have 96x squared plus 336x plus 289. So that is f of g of x, or f circled g of x. Now it did also ask us to go the other direction too. The other direction is actually not going to be quite as bad. This one we had to square a binomial, so that took a while. Okay, so to find g of f of x, and this is equivalent to g circle f of x, this is when we take the function g, which is 4x plus 7, and in the place of the x, we put in the function f. So it's going to be 4 times the function f, which is 6x squared minus 5 plus 7. So like I said, this direction is a little bit faster because we're not squaring a binomial. All we have to do is distribute the 4 and combine our like terms here in the back to get 24x squared minus 13. Okay, number 10, we are asked to find a couple more composite functions here. Give myself plenty of room, sorry. Okay, so this time we've got the other notation. So f circle g of x is f of g of x, meaning we're going to plug g into f. So the function f is the square root of x plus 7. But instead of putting that x in there, we are going to instead, in place of x, throw in the function g. So we're going to have the square root of 3x squared minus 2 plus 7. Combine our like terms to get the square root of 3x squared plus 5. There's nothing we can do to simplify that, even with the x squared underneath the square root. So the only way we'd be able to simplify that is if we could somehow get this factored into the square of a binomial. So we're not going to simplify that. To go the other direction and do G circle f of x, sorry, that kind of looks like a multiplication symbol. There we go. Okay, let's try this again. It's supposed to be open. There we go. This is when we plug f into g. So the function g is 3x squared minus 2. In place of the x, we are going to put in the function f. So we're going to have 3 times the function f squared minus 2. So it's going to be 3 times the square root of x plus 7 squared minus 2. When we square a square root disappears. The power of 2 undoes the radical or undoes the square root. So we're just going to have 3 times the quantity x plus 7 minus 2. I'm going to distribute to get 3x plus 21. And then combining like terms, final answer is 3x plus 19. All right, number 11. This one's kind of a big one here. Move 12 down. So number 11, we are given 2 rational functions, and we're asked to find f plus g, f minus g, f times g, and f divided by g, as well as the domain of each. So let's start with f plus g of x. For this one, I'm going to add the 2 functions together. When adding, I need a common denominator. So I'm going to multiply the first rational expression here by x plus 4, top and bottom. Second one gets multiplied by x minus 2. Now I'm going to choose to distribute in the next step, or after, I guess, the next step. But you can distribute whenever. So I'm going to choose to add the numerators and retain my common denominator. Then I will distribute here in a second. So I'm adding numerators, I'm retaining my common denominator. And now I'll distribute, so x squared plus 4x plus 3x squared minus 6x all over x minus 2 times the quantity x plus 4. So my answer is 4x squared minus 2x all over x minus 2 times the quantity x plus 4. Now, if you want to factor the numerator, you can. There is a greatest common factor of 2x. However, factoring the numerator is not going to help to reduce this at all. So I'm just going to go ahead and leave it like that, but feel free to factor the numerator if you'd like. The domain, we can look at our answer, and we do not want to divide by 0. So we do not want x to be positive 2, because 2 minus 2 is 0. We also do not want x to be negative 4. So x cannot be 2 or negative 4. That's our domain. I, as an instructor, am just fine with students using this notation. But if your instructor requires interval notation, make sure you follow their guidelines. Interval notation, I'll just show real quick. It would be negative infinity to negative 4, union negative 4 to 2, union 2 to infinity. So it's basically showing all real numbers except negative 4 and 2 is the domain. Okay, f minus g. Now, sorry, we've lost our problem, but that's okay. So in this part here with subtraction. We're going to subtract the two functions. Now, I'm going to need a common denominator just like I needed for addition. So to save myself a little bit of time, I'm just going to use this right here. But instead of the plus sign here in the center, I'm going to put a subtraction symbol, since I already worked to get a common denominator for the addition one. So I'm just going to change that to subtraction. But as previously mentioned, you would need to find a common denominator for subtraction. Okay, now I'm going to distribute. When I distribute, I get x squared plus 4x minus 3x squared plus 6x would be a plus 6x. Notice it's a negative 3x being distributed to a negative 2. Combine our like terms, and we get negative 2x squared plus 10x all over x minus 2 times the quantity x plus 4. Once again, just like with the first one, if you want to factor that numerator, go for it, but it's not going to help us to reduce anything. I'm going to go ahead and leave it unfactored. Domain is the same as it was for f plus g of x. X cannot be positive 2 or negative 4. Yep, just moving down everything. Sorry, guys. See if I can. Now I'm losing the 12. Oh well. And we'll move this all the way down. Thanks for your patience. Okay, this is 12. Okay, so we still need to do multiplication and division. So to do f times g of x, this is when we multiply f of x times g of x. And I believe I have these functions correct. Sorry, x over x minus 2. Yep, 3x over x plus 1. Got it. Okay, when we multiply, we do not need a common denominator. We just multiply numerators and we multiply denominators. So multiplication is actually the easiest of the three operations, in my opinion. So that's it. Our domain is the same. X cannot be positive 2 or negative 4. Finally, division, f divided by g of x. So this is where we take f of x and we divide by g of x. I can write this horizontally instead of vertically, so it's f divided by g. Now, when we're dividing two fractions or two rational expressions, we can multiply by the reciprocal of the second one. So I'm going to change this to a multiplication, but I'm going to flip the second. Now, there is one thing we can do to reduce this. We can cross-cancel the x's. So our answer, reduced answer, would be x plus 4 over 3 times the quantity x minus 2. If you would like to distribute the 3 in the denominator, go for it. Doesn't matter. Both are correct. Now, the domain of f divided by g is a little bit tricky. It's the intersection of, oops, I'm going to pause this real quick. Okay, I'm back. Sorry about that. To find the domain, it is the intersection of the domains of f and g, like what we were doing for the other three operations. But you also need to exclude the number that will make g of x equal to 0. So for the domain, we still don't want x to be 2 or negative 4, just as we did with the other 3. But we also need to figure out where g of x is equal to 0, because we're dividing by g, and you can't divide by 0. It's undefined. So we also do not want, so x cannot be that, and we also don't want g of x to be 0. So we've got to figure out where would g of x be 0. So for this, if I need to solve this equation here, I could multiply both sides by x plus 4, and that would cancel my fraction. So multiply both sides by x plus 4. So we have 3x cannot be 0. 0 times anything is still 0. Divide by 3. 0 divided by 3 is 0. So x can also not be 0. So our domain here is we do not want x to be 2, negative 4, or 0. So all real numbers except for those 3 would be our domain. Another way to kind of think of it, and this is what I tell my students. First of all, we can't look at our final answer, our reduced answer. That doesn't that doesn't help us with domain. I just tell them to look back at the unsimplified answer and make sure no denominator anywhere in the problem is 0. So we end up having 3 denominators. We don't want any of those 3 denominators to be 0. So that's why x cannot be positive 2, negative 4, or 0. All right. See if we can get this to go down a little bit. Move this to the next page. Okay, number 12, we have a polynomial function, and we are supposed to graph this, sketch a graph. Also state where f of x is greater than 0 and where f of x is less than 0. First, I'm going to factor the function so that I can find the zeros. I'm going to factor by grouping. I'm going to pull out an x squared from the first 2 terms, and then I'm going to pull out a negative 1 from terms 3 and 4. These 2 binomials must match in order for factoring by grouping to work, and they do. So my factors are x plus 4 and x squared minus 1. And then x squared minus 1 can factor further into x minus 1, x plus 1. It's a difference of squares. So the zeros of this function, the zeros are where f of x is equal to 0. My zeros would be negative 4, positive 1, and negative 1. I'm setting each of these factors to 0 to come up with my zeros. My zeros, as long as they're real numbers, are going to be my x-intercepts. So I'm going to plot negative 4, positive 1, and negative 1. Now, the way I'm going to do this is a little different than the way our book does it. It's also a little different than the way that I showed if you're looking at the review solutions on paper and pencil. So that way I did it the book way. This way I'm going to use multiplicity. The multiplicity of all of these zeros is 1, multiplicity 1, because each factor, its exponent would just be a 1. It's x plus 4 to the first power, x minus 1 to the first power. So with a multiplicity of 1, it's cross for all of them. When we have an odd multiplicity, it crosses. Even multiplicity is a touch. So I'm going to use multiplicity. I'm also going to use end behavior. When we have a cubic function with a positive leading coefficient, this is our end behavior. So I'm going to make sure that my graph is headed down over here and up over here. And then I just cross through those x-intercepts. So this would be a sketch of this function. Just a sketch, okay, not anything super fancy here. If you're going on to take calculus, you'll talk about local minimums, local maximums. You'll be able to do a better job. But for this is just a sketch here. It also asks me where f of x is greater than 0 and where it's less than 0. For f of x greater than 0, I'm going to use blue here to just kind of trace it. This is where f of x is greater than 0. So for that part of the graph, I'm going to use intervals of x values. So when x is between -4 and -1, f of x is greater than 0. Also, when x is bigger than 1, f of x is greater than 0. So those are my intervals for where f of x is greater than 0. We do not want to use brackets. We only want to use parentheses because when x is -4, when x is 1, when x is -1, f of x is equal to 0, not less than or greater than. Okay, in orange here, I've got where f of x is less than 0. That's from -infinity to -4, and then again from -1 to 1. Okay, number 13. So this one is very similar. I'm going to factor, just as I did with number 12. I'm going to pull out an x squared from the first two terms. I'm left with x minus 3. Then I'm going to pull out a -9, left with x minus 3 again. My factors are x minus 3 and x squared minus 9. X squared minus 9 is a difference of squares. It will factor as x minus 3x plus 3. Okay, I'm going to go ahead and since I have two factors of x minus 3, I'm going to write that as x minus 3 quantity squared. My zeros for this one, I only have two of them. Zeros are where f of x is equal to 0. Zeros are +3 and -3. So +3, -3. At +3, okay, because x minus 3 is squared, the multiplicity of this 0 of +3 is a 2, which would make it be a touch. So I've got a touch here and a cross here. Multiplicity is only 1 over here. So +3 is a touch, -3 would be a cross. My end behavior is the same. I've got another cubic polynomial function with a positive leading coefficient. So I've got to go down over here and up over here, but this one's a touch, so be careful. So this is what this graph is going to look like. Sorry, that's supposed to touch. It's kind of close there. So it's going to cross here, but touch there. See if I can make that look a little better. Close enough. Okay, it's touching there. F of x is greater than 0 from -3 to 3, and then again from 3 to infinity. Now, I did split that up into two intervals because when x is equal to 3, f of x is equal to 0, not greater than 0. So I do need to split those two intervals up. And then less than 0 would be -infinity to -3. Okay, 14. This one we are asked to divide, and it is going to require long division. This is because the polynomial we are dividing by, the divisor, has degree 2. So synthetic division can only be done when the degree is 1 of the binomial. And I'm also going to throw in a 0x squared. I like to keep like terms lined up. So by putting in a 0x squared, I can keep everything lined up. I was just noticing that the dividend is missing a term. So I'm going to put in a 0x squared. So we start and we look at the first term of the divisor and the first term of the dividend, and we ask ourselves, what can I multiply 2x squared by in order to get 4x to the fourth? That answer, whatever that may be, is going to be the start of our quotient. So 2x squared times 2x squared gives us a 4x to the fourth. So this is a 2x squared. Oops, sorry, I tried to change colors. Oh well, guess it didn't work. So 2x squared goes up here, begins our quotient. Then we take the 2x squared and we multiply it times each of the terms of the divisor. And we write the result below. When I take 2x squared times 2x squared, I get 4x to the fourth. When I take 2x squared times 1, I get 2x squared. I'm going to write it all the way over here. I just like to line up my like terms. Okay, now we subtract down. The other thing we could do, if you wanted to add down, is you could change both signs, and then you'd be able to add down. So I'm going to go ahead and do that. So I'm going to change this to a negative 4x to the fourth. I'm going to change this to a negative 2x squared, and then I'm going to add down. So either subtract down or change both signs and add down. 4x to the fourth plus a negative 4x to the fourth is 0. The 6x cubed just gets dropped down because I'm not adding or subtracting anything from it. 0 plus a negative 2x squared would be a negative 2x squared. And I am going to drop down my next term, which is a 5x. I repeat this process. I take the first term of the divisor, 2x squared, and I ask myself, what can I multiply 2x squared by in order to get 6x to the third? We'll get the 6x to the third. And that would be a 3x. That goes up here, and it continues my quotient there. Then I take the 3x times the 2x squared and the 1. I write it below. 6x to the third plus 3x. At this step, I can either subtract down or I can change both signs and add down. So I'm going to change both signs, change this to a minus, and then I'm going to add down. 6x to the third plus a negative 6x to the third, done, gone. The negative 2x squared just gets dropped down. This becomes a 2x because it's a 5x plus a negative 3x. Drop down the negative 7. Okay, one more time. What can I multiply 2x squared by to get negative 2x squared? It would be a negative 1. And then I'm going to get a negative 2x squared minus 1. If I change both signs, I can add down. So I'm going to change this to a plus, and I'm going to change this to a plus, and then I am able to add down. This is going to be my remainder. Negative 2x squared plus 2x squared, gone. 2x, negative 7 plus 1 is negative 6. So my quotient is this. Okay, so this here is the quotient. And all the way down here is my remainder, that 2x minus 6. We can have a remainder that is not just a single number, but a binomial like this. We know we're done when the degree of what we have down here is smaller than the degree of our divisor. For 15, we are able to use synthetic division because we are dividing by a binomial of degree 1. The number that goes inside the box is a positive 2. When we're using synthetic division, we say we're dividing by x minus c. So our c would just be positive 2 here. Or just think of what would you get if you set x minus 2 to 0. Up here at the top, alongside the box, I'm going to write in the coefficients of each of the terms. I do need to insert zeros when I have missing terms. So I do have a couple of missing terms. There's no x cubed and there's no x. So I need to put zeros in their spots. For synthetic division, you drop down the first number. Then we multiply that by the number in the box, write it above the line in the next column, and then we add down. We don't change the sign. Up here with long division, we had to change the sign. This we just add down. -4. -4 times +2 is -8. Then we add down -5. Take it times the number in the box, -10. Add down, -10. -10 times 2 is -20. Add down, -22. This last number is our remainder. Then comes the constant, or just the number term. Then comes the coefficient of x. Then comes the coefficient of x squared. Then comes the coefficient of x cubed, so on and so forth. You could also just know that the quotient is going to be 1 degree less than the dividend. So for this one, our quotient, give myself a little bit more room here. So for this one, our quotient would be -2x to the third minus 4x squared minus 5x minus 10. And our remainder is -22. Okay, 16. We have a cubic equation here that we want to solve. And before I use our rational zeros theorem, which is what we need to use, I do want to show you that factoring by grouping does not work. If I tried to factor by grouping, I could pull out an x squared from terms 1 and 2, and I would be left with 2x minus 3. From terms 3 and 4, there's no GCF other than 1. So I could pull out a 1, and I'm left with -17x plus 30 equals 0. So the point of this is you cannot solve this by factoring by grouping. So we use our rational zeros theorem. We're going to put factors of 30 on top, and we're going to put factors of 2 on bottom. Factors of 30 are, we do use a plus or minus symbol because to get 30, we could multiply, for example, +2 and +15, but you could also multiply -2 and -15. So plus or minus 1, 2, 3, 5, 6, 10, 15, and 30. Factors of 2, plus or minus 1 and 2. So our possible rational zeros are, I'm going to take the numbers in the numerator and put them individually over the denominator, numbers in the denominator. So we've got plus or minus 1, 2, 3, 5, 6, 10, 15, 30, 1/2. I'm not going to write 2 halves because 2 halves is 1, 3 halves, 5 halves. I'm not going to write 6 halves because 6 halves is 3, 10 halves is 5. I am going to write 15 halves, and then 30 halves is 15. So if I can reduce to a number already on the list, I don't need to write it again. Okay, so here are our potential rational zeros. Now we need to figure out which of these works into the equation. I'm only going to find one, and then I'm going to use synthetic division to finish the problem. But if you're someone who just loves to plug and chug, go ahead and keep plugging and chugging until you find all that you possibly can. I don't think I'd recommend that. Okay, so I'm checking on my calculator here. I got to find at least one. Okay, I found that 2 works. So if I take 2 and I plug it into the equation for x, I get 2 to the third, which is 8, times 2 is 16, minus 2 squared is 4, times 3 is 12, minus 34, plus 30, and this is equal to 0, which is good, because that's what we've got up here. That's supposed to equal 0. So we have found that x equals 2 is one of our solutions. X equals 2. So one solution, x equals 2. Okay, but I'm guessing there are 3 solutions. It's a cubic equation. Move this all the way down here. So to find the remaining 2, what I'm going to use is synthetic division. I'm going to put the one solution that I found that works in the box. Then I'm going to write the coefficients of the terms. Drop down the 2, multiply times the number in the box, add down, multiply times the number in the box, add down, multiply times the number in the box, add down. I get a remainder of 0, which makes me happy. If you don't get a remainder of 0, go back and check your work. It means the number that you think is a solution is not really a solution, or perhaps you made a silly error in your math here. Now what I have left is a quadratic expression here, but I can make it into an equation, set it to 0, and my remaining 2 solutions I can find by solving this equation. It does factor. I can use the AC method. A times C is 2 times negative 15, which is negative 30. I'm looking for 2 numbers that add to positive 1 and multiply to negative 30. Those 2 numbers would be positive 6 and negative 5. So I can write this as 2x squared plus 6x minus 5x minus 15 equals 0. So this is equivalent because I had a positive 1x in the middle, and all I've done is replace that with a 6x minus 5x. I can then factor by grouping. So I'm going to find a GCF here, find a GCF here. My binomials need to match inside the parentheses, and they will. Pull out a 2x, we're left with x plus 3. Pull out a negative 5, and we're left with x plus 3. So the remaining factors are x plus 3 and 2x minus 5. If I set those to 0, I will get my other 2 solutions. Now don't forget about the 2. That was a solution that we got earlier. Okay, so don't drop that. So x equals 2 is one of our solutions, as well as negative 3, as well as 5 over 2. So I just set each of those factors equal to 0 and solve. So those are my 3 solutions. Our very last one is similar to 16. I've got to use our rational zeros theorem. I'm going to put factors of negative 33 over factors of 1. Factors of negative 33 are plus or minus 1, 3, 11, and 33. Factors of 1 are just plus or minus 1. So our potential rational zeros are plus or minus 1, 3, 11, and 33. Now, just as I did with the last one, I want to find one number that works when plugged into my equation here. Then I'm going to use synthetic division to finish the problem. Okay, so let's see. Sorry, guys. I'm still here. I skipped over 1 and negative 1. Maybe that's it. No? Okay, I must be making an error here. because I'm not finding. Okay, may have to pause the video here. I don't know what I'm doing around here. Oh, +3. I must have done something silly. Anyway, if you plug in +3 into the equation, it works. I just must have had a fat finger on my calculator here. So plugging in 3 gives us a 0. So x equals 3 is one of our solutions. Now I'm going to use synthetic division to come up with the other 2. I'm assuming that I have 2 more since it's a cubic equation. Not always we know about multiplicity, but I feel like that would be very mean of us to have less than 3 solutions when these problems can be quite difficult. So we're going to drop down the 1, multiply times the number in the box, add down. Multiply times the number in the box, add down. Multiply times the number in the box, add down. I get a remainder of 0. Makes me happy. That's good. It means the solution that I think is a solution is truly a solution. The quadratic that I'm left with is x squared minus 8x plus 11. If I set that to 0 and solve, then I will have the remaining 2 solutions. Now, what makes this one different than number 16 is this quadratic equation does not factor. So in order to finish, we are going to need to use the quadratic formula. So that list of potential rational solutions that we made, these are only rational, potential rational, so our other 2 solutions are not rational, so we're not going to see these other 2 solutions on the list we made above. Our A is 1, our B is -8, and our C is 11. I'm just going to plug and chug, so I'm going to have +8 plus or minus the square root of 64. B squared is always positive, even if your B is negative, minus 4 times 1 times 11, all over 2 times A, which is 1. This is going to give me 8 plus or minus the square root of 20, all over 2. I can reduce this or simplify this. Oh, I'm at the very end. Bummer. I do need to simplify the square root first. This is going to move everything down. Yes, it is. Oh, well, at least I'll have a little bit more room. Okay, so sorry about that. To simplify the square root of 20, we get 2 square root 5. And then I can divide all 3 terms by 2. So divide by 2, you get 4. Divide by 2, you get 1. Divide by 2, you get 1. So 4 plus or minus square root 5. Now don't forget the 3. We found 3 was a solution as well. Include that. So 3 is a solution, as well as 4 minus square root 5, as well as 4 plus square root 5. So these are 3 solutions to this cubic equation. Thanks for watching, guys. Good luck on your test.